Hey friends, welcome to the YouTube channel all about electronics. So in this video, we will learn about the Karnaugh map, which is also known as the K-map. So this Karnaugh map is a technique for simplifying the Boolean expression. And by simplifying this Boolean expression, we can reduce the number of logic gates which is required to implement that function. For example, let's say we have this Boolean expression and we want to implement it using the logic gates. Now this expression is in the canonical SOP form. So to implement this expression, we require 3 AND gates and 1 OR gate. And here we are assuming that the inputs in the true form and the complemented form are readily available. But if we just minimize this expression, then we can reduce the number of logic gates which is required to implement this function. So in this way, by simplifying the Boolean expression, we can reduce the number of logic gates, and by doing so, we can reduce the total cost and the required space for that implementation. So of course, as we have seen so far, using the Boolean laws, we can definitely minimize the Boolean expression. But to minimize the expression algebraically, we need the familiarity with the Boolean laws. And as the number of variables increases, then it becomes difficult to minimize the expression algebraically. And after the minimization, we are not sure whether the reduced expression is actually minimal or not. So in such case, this Karnaugh map is a relatively simple method for simplifying the Boolean expression. So first of all, let us see how to construct the K-map for 2 and 3 variables. Then after we will see that how to map the Boolean expression in this K-map, and after that we will see that how to minimize the Boolean expression using this K-map. So for the 2 variables, there are total 4 different combinations. Or in other words, for the 2 variables, there are total 4 minterms. So this is how the 2 variable K-map will look like. So here, the digit beside each row is the possible value of the A, while the digit above each column is the possible values of the B. And the combination of this A and B is represented by the each cell of this Karnaugh map. Or in other words, we can say that the each cell of this map represents the particular minterm. So whenever these A and B are 0, then it represents the A bar dot B bar, and it is represented by this cell. Similarly, when this A is 0 and B is 1, then it represents the A bar dot B, and the second cell represents the minterm M1. Likewise, when A is 1 and B is 0, then that represents the minterm M2, and this last cell represents the minterm M3. That means each cell of the map represents the particular minterm. And for simplicity, we can also denote each cell with the number, where this number denotes the particular minterm which is represented by that cell. So this is how the 2 variable K-map will look like. Similarly, now let us see the 3 variable K-map. So for the 3 variables, there are total 8 different combinations. And this is how the 3 variable K-map will look like. So here, the numbers on the top of each column represents the possible combinations of variable B and C, while the number beside each row represents the possible values of the A. And each cell represents the particular combination of A, B and C. Or in other words, each cell represents the particular minterm. Now here in the K-map, the numbering is done in the gray code form. That means if you move from the one column to the other column, then only one bit is changing at the time. And that is why after 0, 1, we have a 1, 1 instead of 1, 0. That means between each pair of adjacent cell, only one bit is changing at a time. For example, as we move from the first cell to the second cell, then only this third bit is changing. Likewise, as we move from the 001 to the 011, then only the second bit is changing. Similarly, as we move from the 001 to the 101, then only MSB is changing. Moreover, as we move from the 000 to 010, then also only one bit is changing. That means these 2 corner cells are also adjacent, because if we just wrap this map, then these 2 cells will be adjacent to each other. Similarly, these 2 cells are also adjacent to each other. So in short, in the K-map, the cells are arranged such that between each pair of adjacent cells, only one bit is changing at a time. Alright, so now let us see how to map the Boolean expression in this K-map. And in this video, we will assume that the Boolean expression is in the sum of product form. So first, let us take the case of two variables. So here, this f1 is the function of two variables. So to represent this function in the K-map, what we will do, whatever minterms are present in this function, for those minterms, we will put the 1 in the map. For example, in this case, the minterms 0, 1 and 3 are present. So we will put the 1 in those cells. Now many times, we might be given a function in the algebraic form. So from that also, we can map the function in the K-map. For example, the same function can also be given as a bar dot b bar plus a bar dot b plus ab. So here for the a bar dot b bar, both a and b are 0. That means this term represents the first cell. So here we will put the 1 in first cell. Similarly, in case of this a bar dot b, the a is 0 and the b is 1. So for this term, we will put the 1 in this cell. Similarly, for this a dot b, both variables a and b are 1. That means for that, we will put the 1 in last cell. So in this way, we can map the Boolean expression in the K-map. So now, let us see how to minimize the Boolean expression once it is mapped in the K-map. So for the minimization, make the group of ones which are adjacent to each other. But this group should be in the power of 2. That means in case of the two variable map, we can make the group of 2 ones or the 4 ones which are adjacent to each other. But we cannot make the group of ones which is not in the power of 2. For example, we cannot make the group of 3 ones. And during the grouping, just ensure that all the ones in the map gets covered. And during this grouping procedure, even if the two groups overlap with each other, then also that is alright. So in this case, we can make the group of these two ones, and likewise, we can also make the group of these two ones. And in this way, all the ones in the map gets covered. So in this way, by doing this grouping, we can minimize the Boolean expression. And to understand that, first let us consider this first group. So this group consists of two minterms, that is a bar dot b bar and the a bar dot b. Now in this case, since the a bar is common, so we will have b bar plus b, and we know that this b bar plus b is equal to 1. That means this a bar dot b bar plus a bar dot b is equal to a bar. So by grouping these two ones, equivalently we will get a bar. So now let us see how to get the same result from the K-map. So if you see this group, then this variable a remains same throughout the group. On the other hand, this variable b is changing over the group. So we will discard the variable which is changing throughout the group, and we will keep the variable which is not changing. So in this case, as you can see, this variable a is not changing, and here the value of this variable is equal to 0. That means this group represents a bar. Similarly, let us see the second group. So this group consists of two minterms a bar dot b and ab. So if we simplify this expression using the Boolean laws, then we will get the b. And the same result we can also get directly from the K-map. So if you see this group, then in this group, the variable a is changing while the variable b is constant. So in this group, we will keep this variable b and we will ignore this variable a. And here, since the value of b is equal to 1, so this group represents b. That means this group represents a bar while this group represents b. And the overall function is the summation of a bar and b. So in this way, using the K-map, we can simplify the Boolean expression without using any Boolean laws. So let us take one more example. So once again, here the function is the two variable function, and it consists of two minterms, that is m0 and m3. So in the K-map, first of all, let us mark those cells with the 1 which corresponds to these two minterms. So in this case, we cannot make the group of 2 because these two cells are not adjacent to each other. So in this case, just consider these two ones alone. So the first cell represents a bar dot b bar, while this last cell represents a dot b. That means in this case, further we cannot minimize the function, and the output is equal to a bar dot b bar plus ab. Similarly, in this case also, these two ones are not adjacent to each other, and therefore we cannot group them together, and therefore we need to consider these two terms individually. So in this case, this one represents a bar dot b, while this one represents a dot b bar, and the output is the summation of these two terms. On the other hand, if all the cells are 1 in the map, then the output is equal to 1, because irrespective of the change in the variable a and b, the output remains 1. So that is how we can minimize any two variable Boolean function using the K-map. Similarly, now let us see how to minimize the three variable Boolean expression using the K-map. So let's say this f1 is the function of three variables. So first of all, let us map this function in the K-map. So here we will place the ones in those cells which represents these minterms m0, m1 and m5. And now let us try to minimize this function. So as I have discussed earlier, to minimize this function, we need to make the group of ones which are adjacent to each other, and the group should be in the power of 2. So in this case, this is the first group, and by combining these two ones, we will get the second group. And with these two groups, all the ones in the map gets covered. So first of all, let us consider this group. So in this group, if you see, then this variable c is changing, while the variable a and b are fixed. Therefore, for this particular group, we will consider this variable a and b, and we will ignore the variable c. Moreover, since the value of a and b is 0, that means this group represents a bar dot b bar. Similarly, let us see the second group. So in this group, if you see, then the variable a is changing, while the variable b and c are same. So here the b is 0 while c is 1. Therefore, this group represents b bar dot c. And if we see the overall function, then the overall function is equal to a bar dot b bar plus b bar dot c. So in this way, by making the groups in this Karnaugh map, we can minimize the Boolean function. So let us take another example. So let's say this f1 is the function of three variables, and it consists of following minterms. So first of all, let us represent this function in the K-map. That means we will place the ones in those cells which represents these minterms. And now let us try to minimize it. So here in the top row, we can make the group of these two ones, and similarly in the bottom row, we can make the group of these two ones. So first, let us consider this first group. So in this group, the variable a and b are not changing, while the variable c is changing. And here, the value of a and b is 0. That means this group represents a bar dot b bar. Similarly, in this second group, the variable a and c is not changing, while this variable b is changing. So in this group, the value of a and c is equal to 1. Therefore, this group represents a dot c. So if you see the overall minimized function, then that is equal to a bar dot b bar plus ac. Now some of you might have a question that, can we combine these two groups and can we make the group of 4? Well, the answer is no, because we can do so if both the groups are adjacent to each other. Now when we move from the one group to the other group and only one variable is changing, then we can say that those two groups are adjacent to each other. And in that case, we can combine those two groups and we can make the bigger group. So in this case, if you see, when we go from one group to the other group, then more than one variable is changing. Because in this case, this variable a is changing, and at the same time, this variable b is also changing. That means these two groups are not adjacent to each other, and therefore we cannot combine these two groups. So in short, we can make the group of ones which is in the power of 2, and the shape of that group should be either square or rectangular. Now some of you might ask, while grouping, can we cover these two ones first, then these two ones, and then these two ones? Well, you can do so, but just by making these two groups only, we are able to cover all the ones in the map. So there is no need to make this third group. That means during the minimization, try to cover all the ones in the map by making minimum number of groups. So let us take few more examples so that it will get clear to you. So in this case, the Boolean function contains 4 minterms. So first of all, let us represent all these 4 minterms on the K-map. So for that, we will place the ones in each cell which represents these minterms. That is 0, 1, 3 and 5. And now let us try to minimize it. So here, this is the first group of ones. Similarly, we can also make the group of these two ones. And now only this one remains. So by making the group of these two ones, we can also cover that one. So in this way, we have covered all the ones in that map. So first, now let us consider this group. So as we have seen earlier, in this group, the variable a and b is not changing while the variable c is changing. And here, the value of variable a and b is equal to 0. Therefore, this group represents a bar dot b bar. Similarly, in this second group, the variable a is changing while the variable b and c remains same. And here, the value of b is 0 while the value of c is equal to 1. Therefore, this group represents b bar dot c. Similarly, in the third group, the variable a and c is not changing while the variable b is changing. So here, the value of a is 0 while the value of c is equal to 1. Therefore, this group represents a bar dot c. So now, the overall function is the summation of all these groups, that is a bar dot b bar plus b bar dot c plus a bar dot c. So in this way, using the K-map, we can minimize the Boolean function. So let us take few more examples and let us understand the other possible groupings in this 3 variable K-map. So let us consider this function. So first of all, let us map this function in the K-map. So earlier we have seen that the cells at the edge of the map are also adjacent to each other. So if the function contains those minterms, then we can also group them like this. So in this case, as you can see, the variable a and c is not changing. And here, the value of both variable a and c is equal to 0. Therefore, this group represents a bar dot c bar. Similarly, in this case, we can combine these two ones, and this group represents a dot c bar. Because in this group, the value of variable a is equal to 1, while the value of variable c is equal to 0. Now so far in our discussion of 3 variable K-map, we have seen that how to make the group of 2. But now let us see few more examples where we can make the group of 4s, and let us see how to minimize those functions. So let's consider this function. So first, let us map this function in the K-map. So as you can see, it contains minterms 1, 3, 5 and 7. So in this case, instead of making the group of 2 ones, we can make the group of 4 ones. So in this group, if you see, then both variables a and b are changing, but this variable c remains same. Therefore, this group represents c, and the minimized expression of this function is also equal to c. So in this way, by making the group of 4, we can further minimize the Boolean expression. So let us take a couple of more examples. So in this case, first let us map this function in the K-map. So this function contains 4 minterms 0, 2, 4 and 6. So here, instead of making the group of 2s, we can make the group of 4s, because these two groups are also adjacent to each other. Now if you see this entire group, then only variable c is not changing, and the value of variable c is equal to 0. Therefore, this group represents c bar, and the minimized expression of this group is also equal to C bar. So let us take few more examples. So first, let us map this function in the K map. So after mapping, if you see, then these 4 ones are in the same row. So we can make the group of 4. Now in this case, the variable B and C both are changing, while the variable A remains same. And here, the value of variable A is equal to 0. Therefore, this group represents A bar. That means after the simplification, this function is equivalent to A bar. Similarly, in this case, if we map this function on the K map, then we have 4 ones in the bottom row. So here, we can make the group of 4. And in this case, only one variable A is not changing. And since the value of variable A is equal to 1, so this group represents A. So let us take a couple of more examples. So in this case, the function contains 6 minterms. So first, let us map this function on the K map. Now here, we can't make the group of 6 because as we have seen earlier, we can make a group which is in the power of 2. That means here, we can make the group of 2, 4 or 8. So here, to minimize this expression, we can make a group of these 4 ones, and likewise, we can also make the group of these 4 ones. So of course, here the two groups are overlapping, but that is alright. So if we just consider the first group, then only one variable B is not changing, and the value of variable B is equal to 0. Therefore, this group represents B bar. Similarly, if we see this second group, then only one variable C is not changing, and the value of variable C is equal to 1. Therefore, this group represents C. And if we see the overall minimized function, then that is equal to B bar plus C. So now, let us move to our last example. So this function also contains 6 minterms. So first of all, let us map them on the K map. So after mapping, if you see, then we can cover all these 6 minterms using two groups. So the one group is the group of these 4 ones, while the second group is the group of these 4 ones. So if we consider this first group, then it corresponds to B bar, because in this case, only variable B is not changing, and the value of B is equal to 0. Therefore, this group represents B bar. Now if we see the second group, then in this group, only variable C is not changing, and the value of variable C is equal to 0. Therefore, this group represents C bar. That means if we see the overall minimized function, then that is equal to B bar plus C bar. So in this way, through the different examples, we have seen that using the K map, how we can easily minimize the Boolean function of 2 and 3 variables. Similarly, in the next video, we will see the 4 variable K map, and through the different examples, we will see that how to minimize the Boolean function of 4 variables using the K map. So if you have any question or suggestion, then do let me know here in the comment section below. If you like this video, hit the like button and subscribe to the channel for more such videos.